I will hand you over to Rustla to talk through tokens of the kingdom. Knock in there. Hello.
Can you hear me okay? Cool. All right. Hi, I'm Russ. I'm a principal tester at Trustwave, doing things like campaign testing and cloud security assessments. Some of my previous adventures include talking at BSides Perth, last time around here on app control, developing challenges in WACTF a few years running, and talking at Sector's Perth on things like building an AD lab and Bloodhound's site query language. Today we're going to talk about tokens within Microsoft's cloud. For that, we're going to have a very quick, very high-level look at OAuth and how it works, because that's what the tokens use. We're going to look at two of the token types, explore how they work a bit and what they're made up of. Then we're going to talk about the scopes, audiences, and consents, because they're kind of fundamental pieces for the next bit. And then we get into the interesting stuff, which is where you might find tokens or steal tokens from the user. Then we'll look at what you can do with those tokens if you manage to steal them. And for those bits, we're going to be talking or showcasing some tools and techniques developed for other security researchers, and a little bit of sprinkling of my own stuff as well. And lastly, we'll have a look at some ideas for detecting and preventing token replay. And this stuff does relate to the stuff that Matt was talking about first thing this morning, so yay, that was really, really convenient. So tokens, put very simply, are issued by identity providers to clients to access cloud resources, or other things as well, but in this case we're going to be focusing on cloud. And in the Microsoft world, that's things like the resources like OneDrive, SharePoint, Teams, Exchange, Azure, Graph, all that good stuff. And so focusing on the OAuth spec, the two tokens that we're going to be looking at are access tokens, which are used to grant access to those cloud resources, and refresh tokens, which are used to get new access tokens when they expire. There's a few roles within OAuth, and it'd be really useful for us to have a quick look at how they map to Microsoft's cloud realm, or kingdoms, as I really want to call them, because I love Zelda. So we've got the authorization server, which is your identity provider, which is, I can say it, Azure AD. Microsoft wants to call it Azure ID, but it's going to take a while. I'm not there yet. But we've also got the client, which is the app, so things like the Outlook or Teams desktop or mobile apps, Azure command line, that kind of thing. Then we've got the resource server, which are the APIs that underpin those services that the apps talk to, so things like OneDrive or SharePoint APIs, Graph API, that kind of stuff. And lastly, you've got the resource owner, which is the end user, the person that's running an app, who then effectively gives, grants the app access to access their data on their behalf. Very high, very contextual rather than technically accurate overview of how the OAuth flow works. You've got your user, in this case Princess Zelda. She fires up the client, which in this case is the Outlook app. She punches in her creds. The creds are then sent from the client over to the authorization server, or AAD. If all goes well with the login, AAD will send the tokens back to Outlook, which will then include those as headers when it talks to the resource server, which in this case might be Exchange Online. The OAuth access tokens that are issued by AAD are typically going to be JWTs. These have been talked about a lot. I'm not going to bore you with it. Very quick look at the structure, very, very quick. The header, we don't care about for this talk. That's the bit in red. It includes things like, hey, this is JWT, and here's the kind of the algorithm the signature uses. The payload claims, that's the big chunk in blue. We do care about for this talk. Those are the things that identify the user and talk about the scope the token can do, all that kind of stuff. And lastly, we've got the signature, which is effectively used to prevent tampering with the claim, which again, we don't care about. That's the bit in green. Payload claims are basically within the token. They describe to the resource server who the user is and what the token should be able to do. There's a lot of different claims, but the claims that we're going to care about are the audience, which are the resources or the servers that the token can be used for. And in this case, think of it like a URL might be outlook.office365.com. That's what resource the token can interact with. Then you've got the issuer, which is the tenant ID that the user belongs to or that issued the token. The reason that you might want to care about this is because it contains like that tenant ID. If you're using some tools that require the tenant ID, you can just pull them straight out of the JWT to pump them in to your tool. We've got the expiry, which is probably very obvious, but it's also pretty important. That's the time in epoch that the token expires, at which point, hopefully, the resource server rejects access to the resources for that token. And lastly, you've got the scope, which is basically the permissions that the token has over the resource defined in the audience claim. Because client apps act on behalf of users, it's really important to restrict what they can do. And scopes is a way of doing that. When the app is set up and it requests permissions, it can request for just what's required, which is obviously what we would want. So things like if you've got an app that's used to manage tasks, it would have access to read and write tasks, but maybe not access to check your calendar or your email. The other approach you can take is you can ask for the kitchen sink, so everything the user can do, which is the user impersonation scope, and as an attacker, obviously that's what we want. Scopes do require consent before they can be used, and that can be provided by the user for themselves, or it can be provided by the admin for the entire tenant. And you're probably pretty familiar with a consent prompt. This is what the AAD prompt looks like. If you ever fire up your mobile app, it's going to ask you to access your camera location, your dog's birthday, all that sort of stuff. The things we want to make note of here, and obviously if you were going to be doing triaging of apps and consent, you would want to look at the application name. There's a big warning on the screen that it's not published by Microsoft. Looking at how legit this prompt looks, it is a Microsoft prompt. It might inherently result in users trusting this and thinking it is from Microsoft. Then you've got the permissions that are being requested, which you can click on the drop down to get even more information. And lastly, you can cancel or accept the consent. If you click on cancel, the app won't work as it intended to because you've kind of stopped it from being able to access and do the thing it needs to do. Consent can be abused using illicit consent grant attacks, which is basically where an attacker has their own Azure tenant that they control. They create an app registration within it. They tell it what API permissions they want, which is basically the permissions that they're requesting to have of the victim, if the victim goes ahead with it. They give the attacker sends the link to a user, probably through phishing. If the user logs in, consents to that, then the attacker gets the ability to get tokens for them and access things of the tokens for basically what they've requested in the permissions. They've got fairly good control of what they should be getting back, which we're going to take a look at using 365 Stealer. Cool, that is working. That's not working. Yes, it is. All right, I've already registered the app and punched in the creds, so now when we run it, we just get the phishing link. We're going to give that to Link, who's already logged in. And he's going to browse to that link. But it says it needs an admin approval. He doesn't actually have the ability to consent to this for some reason. It says the app's risky and that's all he can do. So he's going to be a good guy and raise his service ticket with Princess Zelda, who does have admin privileges. Zelda can browse the app, see the permission prompt, and see that the permissions are being requested, and read your mail is considered a high impact privilege. Obviously you wouldn't want a user giving consent for an attacker to do that. So Zelda can accept the consent on behalf of everyone, which is the tenant-wide admin, or she can do nothing and start the triage process. So coming over, I've set up a second app registration as the attacker. It's all the same stuff, it just doesn't have that read mail permission. So this is a much lower impact privileges. That is real, it's blurry. Yeah, so now we're going to go, and I've already reconfigured 365 Stealer. We're going to go through and run it again. We're going to spit out the phishing link again. Cool. I'm going to give that to Link, who's going to click on it again. What a champ. Cool, now he can actually see and consent to the permissions because we're asking for a lot less privileged access. It is Link, you can see the permissions there. He doesn't have a problem with it reading his user profile or apparently anyone else's. And we should get an authorization code back, which when coupled with the app registration details you could use to get tokens, and 365 still would do all that, store them on disk. It also does a lot of other stuff as well, like enumerating the user and whatnot as well. Some other ways that you might be able to get tokens is probably pretty obviously through a compromised workstation. Like if you've got a shell of a user's workstation or a beacon or whatnot, you might be able to pull out session cookies. But if you've got an M365 apps, like our friend Toolin does here, Toolin's clicking around the various bits and pieces in Teams, which is making requests to different resources, which is populating tokens in memory. And little does Toolin know, we've got an interpreter shell on his machine. I'm going to run the beacon object file loader to load that to use it later. I'm going to grab the process IDs for Word and Teams. I'm going to pass those to the Office tokens beacon object file written by TrustedSec, which is going to dump the process, grab and scrape it for tokens. So all we need to do is pass the process ID. This first one is Teams. And a whole bunch of access tokens. And to give you an idea of the scale, that's one token. We can do the same for Word just as easily, just change the process ID. Cool. All right, some other places that might be a little less obvious are web apps. A lot of apps these days talk with M365 or graph services, and some of those like to store tokens in local storage. So if you're an attacker and you've got cross-site scripting, you might be able to exfil the tokens to use them. This is actually what inspired the talk for me. I was doing a web app test for a client. I found cross-site scripting and the tokens for various M365 services were stored in local storage. So I tried using Bloodhound Bark to play with the tokens, pull them out, do various things with them, and it didn't work. I got a bunch of errors. I didn't need to look at that any further because there was this really weird thing rolled within the app that meant I could do similar things anyway. But I picked it up a couple of months ago by using the Microsoft's JavaScript, like OAuth login flow demo app, which does very little things, but proved the point what I needed, which was getting tokens and storing them in local storage. And so what I found was that the only issue I had at the time was that if I added an origin header, it would have at least let the request go through the next part. That still didn't work for me in my environment, and I think the reason for that, I didn't have the permissions, it said as much. The permissions I was requesting, the admin had to consent to because the app didn't have access to do that, it hadn't been consented to yet. But I would imagine in a larger environment with an actual usable app, you might be able to do more things with it, but I didn't get a chance to go back and check that. This is a well-documented design decision by Microsoft. The reason that they're storing the tokens in local storage is obviously user experience with the SPA. But they have greatly reduced the refresh tokens down from 90 days down to 1 day just for the SPA type. So that the tokens aren't around for anywhere near as long. If all else fails, phishing might be pretty useful. We've already looked at a illicit consent grant, which you would phish. You've also got things like attacker in the middle with evil Linux and that kind of thing to do some token theft. And there's also device code phishing. You'd be pretty familiar with device codes if you've tried to set up your smart TV to access your streaming services. You get like a 6-digit code on your screen and a URL to browse to. You do that on a phone or a device that's got a keyboard, a bit easier to log in with. But if you were to do this with sending the user like a phish with a URL and a code to enter and a convincing pretext, if they browse the URL, enter the code, log in, then you'll get their tokens and can do things as them. So we're going to take a look at using token tactics. We import the PowerShell module and run the get Azure token command to specify graph, so we get a graph token back. That's spat out the user code there. We're going to give that to Toolin, who is logged in. Toolin knows not to click links in a phishing email, so he's going to browse to microsoft.com/device login, punch in the code. Yes, I'm Toolin. Please let me in. Yes, click on continue. And shortly after, we should get access to refresh tokens. So this token is scope for the audience is the graph, and the scope for this token is user impersonation. So we can do anything that Toolin can do with graph, which is quite a lot. You've got your grubby little mitts on some tokens. What can you do with them? It depends on really two things. The scope, which we just kind of alluded to, you might not have a user impersonation scope, it might be something less, and the audience that it's scoped to. If you can interact with graph, you can probably do quite a bit depending on what the scope is. But generally speaking, these tokens are going to give you some kind of access to one of the many APIs or resources within M365 or Azure, so things like Teams, OneDrive, Outlook, Graph, Azure, Azure AD, those things might all be possible to interact with. The other thing you can do if you've got a refresh token, you might be able to get a new access token to prolong your access. And probably the most interesting, I think, is you can use the refresh token to get access tokens for a different resource. So going from maybe Microsoft Graph to Outlook, which we're going to take a look at. Still within token tactics, we're going to run the refresh to Outlook token command, punch in the tenant name or whatnot, and we get an access token and a refresh token back. We're going to save that to disk, and we're going to run team filtration, which is like a password spraying and post-ex tool. And then we're going to tell it where the tokens are, and tell it an output directory. It's going to run. We're going to run the exfil OA module, which is found in 3 emails. And we're going to browse the disk now. It's 3 HTML files, which I emailed to me. And yeah, so we've got access to the user's mailbox. Similarly, using Graph to go to a Teams token. Again, using token tactics. So one cool thing about token tactics is it will store the outputted codes, output tokens to a variable. You import the AAD internals PowerShell module, which I know Matt mentioned earlier. And we're going to run the get AAD in Teams messages. We're going to specify the variable, the object for the access token. And we're just going to pull out the content and the display name to make it a bit more readable. And we've got messages from Toolin. So there might be some gaps in your tools, or you might be trying to do things that you wouldn't otherwise be able to do because there's no tooling to do it. But these are all just APIs, so Perl, Python, PowerShell, whatever you poison to make web requests can do it. As a proof of concept, I banged together a Python script which interacts with OneDrive. I used Microsoft's documentation to work out what the endpoint names were. There's a bit more fluff in the script, obviously, but the 2 requests, which are obviously the heart of this, are on the screen. The first one is going to interact and search the user's OneDrive for a query that you specify. And it's going to save those to a variable, things like file name and item ID. And the second request is going to download a file by the item ID to disk from a user's OneDrive, which we'll check out. Nothing on the desktop except for the Python script. Run that. It's all hard-coded. We're searching for haiku. If you had a keen eye, you might have seen that when clicking around Teams. Get a 200 response, good. We get a file name and an item ID back, awesome. We've found some results. I've spat out, for demonstration purposes, the URL it's going to target. And we get a response code of 200 back, awesome. No weird, quirky errors with that janky Python code. And we have a file on disk, awesome. Cool, I'm going to open that up. And we've got a really weird haiku. It was totally written by ChatGPT. I can't take credit for that. Okay, M365 services are cool, but depending on the scope and audience of every token, as you might have guessed by now, we could potentially interact with Azure workloads. It doesn't just depend on that. Like obviously, if you've got the scope, the right permissions to do things, and you've got the audience being an API that can interact with Azure, you can do things. But it also depends on whether you've got access to any subscriptions, because workloads and resources run within subscriptions. If you don't have any of those though, you might still be able to interact with AAD, pull out users, groups, app registrations, that kind of thing. I don't have a subscription in my tenant, so I'm going to check out Azure Hound and just query AAD. I'm going to specify the tenant name, output to a JSON file, give it the refresh code from the graph token that we stole, and it's going to run. It's almost finished. We're going to ingest that as a shiny new Bloodhound Community Edition. Okay. That's done. Through the magic of video editing time travel, that's done immediately. That says complete. We're going to go check the database. There's objects in the database now. Awesome. We're going to search to see if Link has access to global admin. Cool, something's showing up. I'm going to try and make it a bit more readable. This is my first time using Bloodhound Community Edition, a little bit different. But yeah, Link has privileged role admin, which means he can grant access to global admin to himself, so that's the attack path. I'd love to have a video to demo this, but I hit problems. Specifically, I got a bad request when running PowerZilla. I quickly toggled over to Microsoft PowerShell Azure, got a different error which I just didn't have the energy to go into. So I looked at the source code to see what the request was doing, and I compared that against Microsoft's documentation and found that the endpoints were just a little bit different. So I excitedly proxied the request through Burp, changed the endpoint and got a different error because I didn't bother reading the post body, which there is also the data type needs specifying. Once I did that, I got a 201 response, which is awesome, and then checked within the Azure portal as well, and Link did have global admin. I've also raised the pull request for that to fix the PowerShell thing as well, so hopefully that gets sorted. Enough about token theft and whatnot. Some ideas that I had and played around with in the tenant to try to fix was looking at refresh tokens. They do show up as non-interactive user sign-ins, so you can view your logs. They do show up there. AAD identity protection has an anomalous token detection, which would also be good, but it didn't work for me. I suspect my demo tenant didn't have enough traffic in it to baseline normal and not normal. Your mileage may vary. In terms of preventing refresh token theft, I had the idea to use conditional access policies to enforce MDM compliance with like Intune. That worked. I wasn't able to replay the refresh tokens by doing that in my tenant. I suspect AAD joined restrictions would also work, but I didn't get a chance to test that. And lastly, from what I saw, access token usage doesn't show up in any sign-in logs and didn't seem to adhere to conditional access policies for me. But Microsoft has rolled out continuous access evaluation, which basically is used to, when certain events occur, like a user resets their password or an admin revokes sessions, the access tokens are no longer able to work for the resources that support them, despite still being valid with their expiry time. This is not an exhaustive list. This is just stuff that I thought of and played around with in the labs. There's 2 links there which are from Microsoft, which cover a bunch more that I haven't covered, but certainly worth a look at. Shout out to all the researchers and for developing tools and publishing research that I was able to showcase today. All the links to the tools that were talked about are on the screen. Any questions?
More of an observation.
Yeah.
A lot of opportunities to make link ones.
Yes, there are. And on that, I did really like my malicious link joke, so I've got about 100 stickers that I printed out for fun. So if anyone wants one, come and find me afterwards, this afternoon, tomorrow, that kind of thing. Cool.
Cool. Any other questions? All right, clap. You started.